Since the early years of humanity, ships were considered indispensable means to travel and the carriage of trade. Since the first ships appeared, people have been trying to make ships faster and more efficient. In order to do that, the propulsion methods have changed during the centuries. From wind to steam to diesel engines and autonomous ships, vessels' propulsion is a constant struggle to innovate. While lately, the need for greener transportation is the driving force behind new propulsion methods. Let's take a look on how ship engines have evolved throughout the years and what the future holds. Until the application of the coal-fired steam engine to ships in the early 19th century, oars or the wind were mainly used for ships' propulsion. Back then, merchant ships were using sail as well as rowing, which was preferred as it offered maneuverability and speed. Until then, and the introduction of engines, sail had been abandoned by shipping as a means of propulsion. However, lately more and more developments are taking place, harnessing wind power to provide propulsion for ships. In the 1700s, steam was one of the main power sources for marine propulsion. As a matter of fact, in 1769, there was a large influx of steam ships as the steam engine underwent large advancements during this time. Early steamships were fueled by wood, and they were using stern or side paddle wheels, which later gave way to screw propellers. The next generation of steamships was using coal or fuel oil, while the first commercial success can be found at Robert Fulton's North River steamboat in U.S. in 1807. Moving on to the second half of the 20th century, increasing fuel costs led to the demise of the steam turbine. In fact, since 1960, most new ships have been built with diesel engines, which was a revolution. As a matter of fact, most modern ships use a reciprocating diesel engine as their prime mover, due to their operating simplicity, robustness, and fuel economy compared to most other prime mover mechanisms. Hello everyone, and welcome back to our channel. Today's video is about how engines of ships have evolved over the years and talk about the significance of engines made up of cast iron. But before, make sure to subscribe to the channel for more similar content. Let's dive in. Marine engines on ships are responsible for propulsion of the vessel from one port to another. Whether it's a small ship plying in the coastal areas or of a massive one voyaging international waters, a marine engine of either 4-stroke or 2-stroke is fitted on board ship for the propulsion purpose. The marine engines are heat engines used for converting heat, which is generated by burning fuel into useful work, i.e. developing thermal energy and transforming it into mechanical energy. The engines used on board ships are internal combustion engines, A-type, in which the combustions of fuel takes place inside the cylinder and the heat is generated post the combustion process. As mentioned earlier, IC or internal combustion engines are mainly used for marine propulsion and power generation purpose. The working of the marine engine can be explained by the following procedure. The fuel is injected at a controlled amount at high pressure. A mixture of fuel and air is compressed inside the engine cylinder with the help of a piston, which results in the explosion of the mixture when pressurized due to compression. As a result, heat is released, which increases the pressure of the burning gas. The sudden increase in the pressure pushes the piston downward and transmits the transverse motion into the rotary motion of the crankshaft using connected rod arrangement. The explosion is repeated continuously for maintaining the power output depending upon the type of marine engine and its usage. The crankshaft is connected via a flywheel, either to the alternator or to a propeller arrangement for doing the mechanical work. To obtain continuous rotation of the crankshaft, the explosion has to be repeated continuously. Before the next explosion, the used gases are drawn out from the cylinder through an exhaust valve and fresh air is supplied, which helps to push the used gas and also to provide fresh air for next combustion process. The size of the ship engine varies from ship to ship, type of stroke it has, and its power output. The ship engine can be as high as a 5-story building, and to accommodate it, the ship engine room has to be designed accordingly. These marine engines are built at the facilities of the manufacturers. For e.g., MAN Diesel has production facilities at Augsburg, Copenhagen, Frederikshavn, St. Nazaire, Shanghai, etc. Similarly, Wärtsilä has facilities in Finland, Germany, China, etc. The ship's engines can also be made in reputed shipyards if there is a contract between the two companies. The most common materials used for making the ship's engine and different ship engine parts are bedplate, The bed plate is the bottommost portion of the engine, which is the base of the engine and accommodates crankshaft bearings and A-frame. For the small engine, a single casting of cast iron is used for two large stroke engines. Fabricated cast steel transverse sections with longitudinal girders are used. A-frame. The A-frame, as the name suggests, is similar to the shape of letter A and is installed above the bed plate of the engine. It is built separately to carry the crosshead guide, and on top, it supports the base of the entablature. The bottom surface of the A-frame is machined for making a mating surface to install it on top of the bed plate. Entablature. The entablature, also known as cylinder block, is made from cast iron and used to accommodate the cooling water and scavenge airspace. Depending upon the size of the engine, the casting can be either for individual or multi-cylinder bolted together. The lower portion of the cylinder block is machined to form a mating surface and fastened with the A-frame using fitted bolts. With that being said, most ship engines, especially those that belong to bigger cargo ships and cruises, are made from iron and not steel or aluminum. Cast iron has a number of properties which make it attractive for engine blocks. Sand casting of iron lends itself well to mass production of complex shapes, including internal voids for cooling and oil channels. Iron casting is relatively cheap and not prone to defects. Cast iron is very fluid when molten and doesn't require expensive one-off tooling, so it is relatively easy to design for manufacture. Very high stiffness as a combination of material properties and the fact that casting is practical ways to make stiff, well-optimized shapes. Good vibration damping. High dimensional and thermal stability. Can be hardened for excellent wear resistance, and wear surfaces, such as cylinder bores, can be integral to the casting. Good machining properties. Adequate corrosion resistance. The tensile strength of cast iron is mediocre, but engine blocks are usually designed for high stiffness, and not so generally that highly stressed anyway. In comparison, aluminum alloy blocks can give significant weight saving and have good cooling properties, but need separate steel liners for wear surfaces like cylinder bores. It is also prone to galvanic corrosion, and tapped holes are prone to failure. Cast steel blocks can give significant improvements in strength, but casting steel is significantly more difficult and expensive than cast iron, and more expensive to machine. Also, an aluminum block weighs less but costs more. An iron block weighs more but costs less. That said, aluminum blocks usually utilize steel cylinder sleeves for increased service life through increased wear resistance. Aluminum expands and contracts considerably more than iron does, and also heats and cools more quickly. Gasket leaks are very common on aluminum engines. The other different ship engine parts which are fitted inside the engine are piston, liner, cylinder, connecting rod, crankshaft, camshaft, fuel pump, exhaust valve. So to summarize everything up, we've seen how engines have evolved over the years from steam ones to combustible ones. Once that move was made, it was a question of optimization of cost, size, and weight that led most ships to choosing iron-made engines over aluminum or steel-made engines. That was all from us today, folks. For more similar content, make sure to subscribe to the channel. See you in the next one.